What if our universe isn't the only one? What if billions of years ago another universe brushed up against ours and left behind a scar we can still see today? This isn't a joke. It's one of the strangest mysteries ever found in the cosmos, something scientists call the cosmic cold spot. Back in 2004, when NASA's WMAP satellite was mapping the afterglow of the Big Bang, astronomers noticed something odd. A massive patch of sky about 1.8 billion light years across that was significantly colder than the rest. Now, the universe is supposed to have tiny temperature fluctuations in the cosmic microwave background. That's normal. But this region, it was too cold, too big, and too weird. Some cosmologists brushed it off as a coincidence, a random statistical blip, but others weren't so quick to dismiss it. To them, the cold spot looked like evidence of something much bigger, maybe even a parallel universe colliding with our own. That's right, this one strange patch of sky might be the first physical sign that the multiverse is real. Of course, not everyone agrees. The cold spot has sparked 2 decades of heated debate. Is it just a cosmic fluke, or is it proof we are not living in a lonely universe after all? By the end of this video, you will see why the cold spot is still one of the most baffling and controversial mysteries in all of astronomy. So, let's begin. To understand the cold spot, we need to rewind back to the early 2000s. NASA had just launched a mission called WMAP, short for Wilkinson Microwave Anisotropy Probe. Its job? To create the most detailed map ever of the cosmic microwave background, or CMB, that faint afterglow left behind by the Big Bang. Think of CMB as baby pictures of the universe. It's light that's been traveling across space for nearly 13.8 billion years, carrying with it a snapshot of how the cosmos looked like just 380,000 years after everything began. Now, scientists expected to see tiny temperature fluctuations in its glow, little warm and cold spots scattered randomly, and for the most part that's exactly what WMAP found. But then came the anomaly. Nestled deep in the southern hemisphere of the sky was a region so unusually cold that it stood out immediately. We are talking about an area roughly 1.8 billion light years across, making it one of the largest structures or anti-structures ever detected. To put that in perspective, if the Milky Way were a grain of sand, this cold spot would be the size of a beach. It was that enormous. And compared to the surrounding regions, it wasn't just a little cooler, it was drastically off the charts. At first, scientists double-checked their instruments. Maybe it was a glitch, maybe WMAP needed a reboot. But follow-up missions like the European Space Agency's Planck satellite confirmed the same result. The cold spot was real, and it wasn't going away. What made it even stranger? No one had predicted something like this. Standard cosmology didn't have a neat explanation, which meant right from the beginning the cold spot was less of a discovery and more of a puzzle waiting to be solved. Once the reality of the cold spot was confirmed, scientists were left scratching their heads. What could possibly create such a massive frozen patch in the fabric of the universe? Over the years, 3 main theories have emerged. The first explanation is the simplest: a cosmic fluke. In other words, the cold spot might be just a random statistical oddity. Imagine tossing a coin 10,000 times. Every now and then you'll get a crazy streak of heads in a row. Some cosmologists argue the cold spot is the universe's version of that streak. Improbable, but not impossible. The problem? The odds are tiny. So tiny that many scientists aren't convinced luck alone can explain it. The second theory is the supervoid. A void is a region of space with far fewer galaxies than usual. Think of it as a cosmic desert. Photons from Big Bang travel through these deserts and lose energy in the process, making the region look colder. That seems like a neat explanation until you run into the math. Even the largest voids we detected simply aren't big or empty enough to explain a cold patch this massive. It's like blaming a pothole for swallowing an entire highway. And then there's the wild card, the multiverse theory. Some cosmologists suggest the cold spot is a scar, the lingering evidence of our universe colliding with another bubble universe during cosmic inflation. Picture 2 soap bubbles bumping into each other, leaving behind a warped boundary. If that happened on a cosmic scale, the cold spot could be the bruise we are still seeing today. It's a bold idea, but it's also the one that makes this mystery irresistible. Because if the multiverse explanation is true, the cold spot isn't just a cold patch in the sky, it's evidence that our universe might not be alone. Of all the theories surrounding the cold spot, none capture the imagination quite like the multiverse explanation. It sounds like science fiction, but it's rooted in a very real idea from cosmology: inflation theory. Right after the Big Bang, the universe expanded faster than the speed of light in a fraction of a second. But according to inflationary models, this expansion might not have been a one-time event. Instead, it could be eternal, creating countless bubble universes within a larger multiverse. Our universe would be just one bubble among many. Now, if these bubbles can form, they can also collide. And when they do, the aftermath would leave behind a kind of bruise, a distortion in the cosmic microwave background. The cold spot, some argue, could be exactly that, a scar left over from our universe brushing against another. Back in 2015, researchers at Durham University studied this possibility. Their conclusion? The cold spot was too unusual to be fully explained by voids alone. That left the door wide open for something more exotic, like a multiverse collision. And as you would expect, that idea spread like wildfire through both the scientific community and the public. After all, who doesn't want proof that other universes exist? But here is the catch. While the cold spot is consistent with the multiverse idea, it's not proof. At least, not yet. It's like finding a footprint in the woods. It could be from Bigfoot, or it could be just someone in weird shoes. Still, the cold spot remains one of the most tantalizing hints we've ever had. If the multiverse is real, it would mean our universe isn't the whole story, just one chapter in an infinite library of realities. And that's an idea too big to ignore. Now, before we all start packing our bags for a trip to universe number 2, it's worth mentioning not everyone's buying the multiverse explanation. In fact, a lot of cosmologists roll their eyes at the idea. Why? Because as exciting as it sounds, the evidence just isn't solid enough. One of the strongest counter-arguments comes from more recent galaxy surveys. In 2017, researchers used the data from Dark Energy Survey to look closely at the region of the cold spot. What they found was a large supervoid, bigger than anything we've seen before. Not quite big enough to fully explain the cold spot, but still impressive. Some argued this discovery meant we don't need exotic explanations like the multiverse, just a really empty patch of space. Others argued the cold spot might simply be a statistical fluke. Sure, it's rare, but rare things happen in a universe this big. It's like winning the cosmic lottery, unlikely but not impossible. In this view, the cold spot is interesting, but not evidence of anything new, just noise in the data. There is also the problem of testability. The multiverse theory is fascinating, but how do you actually prove it? If other universes exist beyond our own, they might forever be out of our reach. And science, at its core, demands evidence. No matter how cool the idea is, you can't test it. Many scientists won't call it science. So the debate rages on. Is the cold spot a void, a coincidence, or a cosmic bruise from a neighboring universe? The frustrating and exciting truth is that no one knows. And until we get better data, the arguments aren't going anywhere. So here we are, over 20 years after the cold spot was first discovered, and the mystery is still unsolved. We've had satellites confirm it, astronomers debate it, and entire papers written about it, but the truth remains elusive. If it's just a cosmic coincidence, then the cold spot is nothing more than a statistical hiccup. The universe rolling dice and coming up with a result that looks suspiciously weird. If it's a supervoid, then we've uncovered one of the largest empty regions ever found, a discovery that still challenges our understanding of how galaxies form and cluster. But if it's something more, if it's the scar of a multiverse collision, then the implications are staggering. It would mean our universe is not unique, that somewhere beyond the edge of what we can see, other universes exist. Perhaps with their own laws of physics, their own stars, their own life. Maybe even versions of us asking the same question. And that's what makes the cold spot so compelling. It forces us to confront the limits of what we know and what we might never know. For now, the cold spot sits quietly in the southern skies, a silent riddle etched into the afterglow of the Big Bang. Is it a proof of another universe or just a trick of cosmic chance? Until we get sharper data, the answer will remain out of reach. But maybe that's the real beauty of it. The cold spot reminds us that the universe isn't fully mapped and the biggest discoveries might still be hidden in plain sight, waiting for us to notice. So, what do you think? Fluke, void, or proof of a multiverse? Let me know in the comments. Thank you for watching, keep looking up.